My name is Lukas. Today I want to talk about building KRM-powered product APIs. First about me, my name is Lukas. I'm a software engineer at Schwarz Digits. Maybe you already heard of us. So we are building a sovereign cloud platform for Europe. We are part of the Schwarz Group, which is mainly known for the big retail companies behind the Schwarz Group. So we have also a few other brands. There were this template thingy, and I thought the overview of all the different logos is kind of cool, so I added it to my presentation. So these are all the brands from the Schwarz Group, and Schwarz Digits is one of them. So we do a lot of things. We also do cloud. So SDKs is our cloud platform we are working on. Check it out. But today, I want to talk about product APIs and give you an idea or a different angle how you can maybe build your product APIs. And that's with KRM. But first, let's look at the classical way how most people do it, or I think most people do it. You have just you have your product API. Of course, you have your Kubernetes cluster, and you have some kind of REST-like product API, right? So you interaction with the user. Hopefully, you have users, and in the background, of course, you also have some kind of product team who's building this API thing, and you deploy it and go for it, right? That's it. So we are done. But there are a few things more you need to think about when you're building your product API. So that's not all of it, right? You have the customer doesn't use your API directly. You have always some kind of client-side tooling. You have a CLI maybe for debugging or trying out the stuff. You have an SDK so people can integrate your product API into their own software. And maybe on top of that, depending on your product API, you maybe have a Terraform provider, so they can integrate it in their infrastructure as code as well. So, and you need to build those things for your product API, so you can provide them to your clients, to your users. When it comes to clients, you also need some documentation, of course. They need to know how to use your product, so you need to also provide this. And, of course, some security stuff, right? So you need authentication, so you want to know who is the user who's trying to log in or who's actually logged in. You have authorization. Is this user actually allowed to use this API right now, or is he not? And then audit logging for audit stuff. You want to know who did what at which point on your API for your safety and also for the safety of your client. So you also need an audit trail you need to store. So it gets a little bit more complicated in the first picture. Then we have a state, of course. We need to store our stuff, our product, somewhere. So we need a database, Postgres or something, which we need to, the state of the product and the state the customer booked or whatever, right? And then we hopefully don't only have one customer, but multiple. So we also need to think about multi-tenancy. We want to separate clients from each other for security purposes and also for to reduce the blast radius. If something goes wrong, you don't want to have an effect of all your users, but only a few of them, hopefully very few. So now we are very successful with our product API. So we're building another one. And this new API need a new team, since the first team is busy maintaining the old one or the first one. So we have now a new API with a new team, and of course they come up with a new data schema, right? The other people, so they think about how can I build this stuff. So this is our new data schema. So now we have two different data schemas since they don't talk to each other, right? But what we already thought about centralizing the common stuff, right? We only need one way to authenticate the user, one way to authorize it, and only one audit trail. We don't put this in every product API, so we already have a central point, an API gateway, where everything goes through. Then, of course, we have standards. we have two different product APIs, and we want to have a one look to the outside world, one view on the API. So hopefully the teams at least talk about the API to each other, so it doesn't look every API look different, but looks at least a little bit similar. Same actions, same kind of resources or resource patterns. So we have a standard here, at least internally, how we build our product. But if you introduce a new standard or an API standard, we need to think about backwards compatibility, right? We don't want to just shut down the old API we had, and now we have a new standard. Please use this one, and you can't use the old one anymore. We need to think about the users. You can't just give them a new API and don't support the old one, so we need some kind of migration path as well. And for that, I had a colleague with which I checked the slides beforehand, said, hey, you can add this XKCD about it. So when we're thinking about standards, there's this XKCD about it. So now we have a new standard which compete to each other, right? So, and we have a lot of custom stuff. We have our API, which is custom made. We have different data schemas, which are also customly made by the different product teams. And we have all the clients. Hopefully, they are at least one client for every API of your company and not multiple ones, but also they are custom made for your API. And you already see that this, in which direction this goes. Can't we use something which is already there, so we don't have to reinvent the wheel here with all this custom stuff? And actually, I don't focus on my product anymore. I'm focusing on, I need the gateway, I need the clients and stuff, right? And then this new approach comes in, or this, it's actually not a new approach, but an approach I want to present to you today. So you see it on a different angle maybe, to use the KRM, the Kubernetes Resource Model, actually for your product API, not just for your infrastructure in the background. KRM is the Kubernetes Resource Model. I guess most of you already know it. It's the approach how the Kube API is built. So I switch the API gateway I had before with the Kubernetes API. I force my product to be a declarative one, so it's resource-driven, and not anymore this I execute an action, wait until it's done, and then I get a result. I just describe what I want to have, and in the background something tries to get to this target state asynchronously. So we are in a declarative state now, which is already defined by the Kubernetes Resource Model. So I don't have to think about that. Everything I offer in my API is a resource now, multiple different resources, which you can define with the custom resource definitions. And instead of having an extra API gateway, I just use the Kubernetes API, which already has built-in features and integration paths for authentication. You can easily plug in OIDC into your Kubernetes API. Authorization, you have the built-in RBAC, but you also can use external authorization systems. And audit logging as well. So Kubernetes already comes with audit logging with a lot of features you can configure, functionality, what you actually want to audit log here. And we replace the actual backend with the product controllers now, so we don't have any this API backend anymore, but we have controllers now. We switched our distributed state from the different products to a central state, which is the etcd from Kubernetes. We already have it, so why don't we use it? And then we had the different custom clients before, and now we can just use existing stuff. We don't have to build these clients anymore. We just use kubectl, or some people say kubectl. We can just use the Kubernetes SDK to integrate into the product, or user can integrate into our product. So we don't have to worry about this anymore. And there's also a Terraform provider, which you can just use. And it's not only supporting the base resources from Kubernetes, it's also a built-in resource for generic manifests, so you can just use it for every kind of resource. So, but now you're thinking, go back maybe one thing. Now we're thinking, are you nuts? Why don't you want to expose your Kubernetes cluster to the outside world? So when there are security guys here, so maybe they tell me now it's another good idea to expose your orchestration platform directly to the outside world, directly to the user. And you're right, I don't want to do that. So that's why there is a little thing called KCP. KCP is a lightweight Kubernetes version. It's compatible with Kubernetes, with the Kubernetes API, but it's a standalone application in your Kubernetes cluster. It's just like all your other applications. You can just deploy to your Kubernetes cluster and can expose KCP to the customer, to the outside world, and get the same kube API you already know. But with the difference, KCP does not support runtime resources. You don't have pods, you don't have deployments, no stateful sets, but you don't need those, right? You only need your custom resource definitions, which you want to provide for your product. So, and the data store is also different from the one we had in our Kubernetes cluster. We have an extra etcd, it's still etcd, but it's not the one from your Kubernetes cluster. So those are all separated. We have the same integration we had before with the Kubernetes. We have still the authentication hooks, for example, with OIDC. We have still the RBAC. We have still the audit log. So we still can use those features as we could do with the standard Kubernetes API. But in a lightweight version, we can just spin up KCP. And in KCP, you already have built-in features for scaling. So they call it sharding and partitioning. I think this is a whole talk on himself, what you can do there, but you can easily scale KCP to handle all the load you maybe hopefully have on your product API, which is not what you have out of the box with your Kubernetes API, right? So there is some talk about if you have too many resources, it's get problematic, which you not that easily get with KCP, since you can easily scale horizontally with also multiple etcd clusters. So now we have now switched our kube API with KCP. Still, the rest is still the same. We still have our controllers with now interact with KCP instead with the kube API. They are completely separate API servers, and we have a central state for all our products in etcd, which is also a central state which we can back up then here at this point. We extend, like with kubectl, with the kube API, we extend the whole thing with custom resource definitions, and then we have our new product API. So I mentioned before one thing, which was the multi-tenancy, which we didn't solve yet, or we didn't talk about yet. And KCP already brings a feature to solve this issue for you, which is called workspaces. You don't get only one kube API, you get multiple kube APIs, one for each tenant, or one for each workspace, actually. So you can spin up a workspace for every tenant. A workspace is a logical cluster from the perspective of KCP. So for each tenant, you can spin up one or more workspaces. It's just another resource in KCP. And you get a new API server, an API endpoint. And then you can separate your tenants by these different endpoints. And your product controllers doesn't need to connect to every single logical cluster. But there is something which is called virtual workspaces, which is an aggregation of all the different tenants you have. So you have still one view to gather the information from the different tenants, but every tenant only gets the view of his own workspaces. right? So with the new approach, we have a KRM API, which, as I said, is declarative. If you didn't have one before, this is forcing you to have a declarative approach, which is resource-driven. So every product or every endpoint is in the end a resource. So you don't have a endpoint with a few JSON things. You always have to declare a full resource, and then you could create or modify this resource via your KCP API. We can reuse existing standards. The Kubernetes Resource Model is known. The different clients are known. We have versioning with our schema, so we can easily version your schema, your custom resource definitions, and support multiple versions in parallel. So this is also already in there. We have the multi-tenancy, which I just described to you, with the workspaces, and we have a single point of truth with the etcd in KCP, which we can then use for backup and recovery if we need it. We have the full Kubernetes ecosystem with all the tooling we already know, which we can use on KCP as well. And the security integration we already talked about, right? So this is another slide I found in the template. I just wanted to put it in here as well. And that's it. So hopefully you get some ideas out of this talk. You can give me feedback. I got this QR code. And there's also 2 links which can be used to contact me. And yeah, thank you very much. Yeah, please speak loud.
Maybe I didn't catch it at the beginning.
Yeah.
This sounds interesting, but what would make it more real in my head is some example.
Mm-hmm.
What might, tomorrow maybe I'm going to develop a new product, and is this for every product, or do you have some examples of products that use this API?
So we are using this approach for our distributed cloud product. So we have the public cloud product, Stackit, and we're also working on a private cloud option where we want to use this approach. So everything is a resource in this approach. So you get a connection to KCP, logging via a OIDC connection, and then you can just, for example, create a virtual machine resource. And in the background, this information gets used to spin up the actual virtual machine, and the status is reported back to your resource status. So you can check then via the API what is the status, and you get, for example, your public IP via the status, and so on, right? And the same applies for every cloud resource. You can imagine a Kubernetes cluster, right? You can spin up with KCP a Kubernetes cluster in the background, and then you get back the status information of your cluster, and then can connect to your actual runtime environment, which you can use for your own product, right?